Okay, in this one we're going to do hypothesis testing and then confidence intervals where we're comparing two proportions. So we've got an industrial process, the manager has changed the method and basically he wants to change the proportion of effective parts he's getting. So for the old method he's got 200 parts sampled, 20 were defective, and the new method 250 parts sampled and 15 found defective. So I want to test the 5% significance level. So let me recap the cheat sheet. So hypothesis test two portions. So we've got two portions which were denoted by P1 and P2, and the null is that they're the same and the alternatives are different. It's proportions, so we have a Z test, and what we're going to do is we look at the difference between them as estimated by the sample, and we have a standard error. Notice again, like with the single proportion, the standard error for the hypothesis test is different to the standard error for the confidence interval. Okay. So let's start off by writing the little one alternative. So H0 is the P1 minus P2 equals 0, and the alternative is that P1 minus P2 is not equal to 0. So first thing you want to do is you want to get the value of the test statistic, so the observed value of the test statistic is, okay, so let's enter some data in. So for the first sample, x1, the number of successes is, so we had 200 parts and 20, so it was 20, so the number of effective 20, the number of parts was 200. For the second group, x2, the number of parts that were defective was 15, and the sample size, the number we sampled was 250. So P1 is the proportion of the sample, the first sample that were defective, so that's x1 over n1. P2 is the proportion in the second group that were defective. And I want the difference between these, so it's P1 minus P2. So the P1 and P2 I calculated here are the same in my cheat sheet as the P1 hat, P2 hat. So there's the difference, 0.04. Next thing we're going to need to do, if we go back to our cheat sheet, is we need to work out the standard error. So we need to get this, what is just called P hat, which is x1 plus x2 over n1 plus n2. So P is x1 plus x2 divided by n1 plus n2. Okay. And then the standard error is this term here. So standard error is going to be the square root of, we want P times 1 minus P times 1 on n1 plus 1 on n2. So that's our standard error. So finally our Z will equal the diff divided by that stuff we had there, the ants. Let me just call that a standard error. So Z equals diff over standard error. It's 1.5743. So it's 1.5743. So we need to get a p-value. So we've got our 1.5743, what we've observed. We've got the negative of that. We've got a standard normal because we've got Z, and we want the blue area. The easiest way to get that is work out using the CDF, the area to the left of this, and times it by 2. So basically we want norm CDF, we want negative Z. That gives the blue area to the left, and we're going to times that by 2. It's about 0.1154. So we've got the p-value is. So we retain the null hypothesis as the p-value is greater than 0.05. Better spell that right. Okay, the 95% confidence interval now. So let's go back and look at the cheat sheet. So we need to calculate our z star. It's going to be p1 minus p2. So that's our diff, which we've already done, plus or minus. We're going to do the standard error as well. But we've calculated p1 hat and calculated p2 hat. So it's just the z star. So what would the z star be? Again, it would be a normal, but now we'd have to choose the point here such that this area is 0.05. So if we think about it, what we want is this to be 0.025. So this would have been minus z star. This is z star. The area in the middle is 0.95 because we're on 95% confidence interval, etc. So let me just indicate we want this is going to be this area here. This is going to be this area here. This is going to be this area here. So basically we want a point z star and minus z star such that the orange area is 0.95 because 95% confidence interval. The blue area is 1 minus that, which is 0.05. And then because these are even sides, we split them. So we want to find the z star minus z star here, such as this area here will be 0.025. So we use norm inverse 0.025. So z star is minus z star is minus 1.96, so z star is 1.96. So let's work out the rest of this standard error. So we've got our new standard error equals 1 square root of, first of all, we've got p1 times 1 minus p1 divided by n1 plus p2 times 1 minus p2 divided by n2. Is that right? So we've got p1 1 minus p1 over n2, so n1, p2 1 minus p2 over n2. So that's my standard error. So now we're going to have diff to the minus sign, our z star, which is 1.96, times by SE. And R plus SE. So this is our 95% confidence interval for the difference. So let's copy that. And here's our right one. So before, you always put the lower one to the left and the larger one to the right. So there we are, there's our confidence interval for the difference, and there's our hypothesis test for difference. Okay, that's it. See you.